What's up, mga chimek? So, it's your boy, Sir Jello, once again for another episode on quantum numbers. So, first, I'd like to congratulate you for answering the task properly. Most of the students got the correct answer. No? However, some students, I think, got tricked with an item there. No? While some, I think, found difficulty in answering the tasks that were given. So, for today's session, we are to strengthen the core knowledge, if not to fully understand or fully gain the skill in identifying quantum numbers, I think to increase at least the skill needed in order to acquire the quantum number. So we'll try to solve at least 5 practice problems. So are you ready, mga chimek? Let's go! Alright, so in the video, sorry for that long hair. In the video, I've learned that we've already discussed the Bohr model and the quantum model. We differentiated them, though I've mentioned that many scientists contributed in the development. We have been bombarded when we were in junior high school about the Bohr model, specifically when we talk about electron configuration. While in the real world, as of the 20th century, the Bohr model was no longer accepted. Though again, as I was saying, it was well celebrated by the people before because the goal of the science is to create a unified law, a single explanation to all, meaning from the macroscopic to the microscopic level. Like this Bohr model, the electron says that it moves around in an orbit attracted by the nucleus, just like planets attracted by the sun in the solar system. That's why the Bohr model was called the planetary model. However, it was debunked by Schrödinger, Broglie, Heisenberg, even Einstein, and many scientists who contributed to the quantum mechanics model. So, si classical mechanics na disregard in Newton, and the quantum mechanics subject in physics was given birth. So, the quantum mechanics model says that the electron cannot be found at a specific location. It can be at 2 places at the same time. Or, in short, we cannot pinpoint the exact location of an electron. The Heisenberg uncertainty principle and the Schrödinger's wave function will further explain the reason behind that. So that's the quantum mechanics model, or we also call it the electron cloud model, where the electron is moving around in an orbital, or in an orbital kasi inadapt yung orbits ni Bohr, but these orbital are just boundaries. These are region in space. These are not the ellipses, or the pathway of the electrons, but rather just like a wall, where the electron might be found. Again, might be found because they can transfer from one energy level to another energy level. And this is the reason why, if you've noticed, many sci-fi movies came into the picture. Even Ant-Man, diba? He would shrink as small as an electron because in the quantum world, time does not work, similar to our world. And then multiverses came into the picture, the possibilities of other you from other universe. If you want to learn about it, you might want to take physics in your college and nag-promote. Or simply, as of the moment, I think one of the best movies that that is guided by science is the Interstellar. If you watch that, maybe you'll understand, you'll appreciate the wonders of quantum mechanics. Well, anyways, now let's focus on the given, the quantum numbers. The quantum numbers, as I was saying, gives us a possible location of where the electron is. Now, the quantum numbers are the following. Now, we have 4: principal quantum number, angular momentum quantum number, and then magnetic quantum number, spin quantum number, all with their symbols, N, cursive L, M sub cursive L, and MS. So basically, as I was saying, si quantum numbers is just like an address. So halimbawa, hanapin natin ng electron ng, let's say, hydrogen. So it has a nucleus with 1 proton. Yan, lagyan natin 1 proton and 1 neutron. Pwedeng dalawang neutron, isotopes, we call it. The Bohr model would say the electron is here, but it's not true. No, the quantum mechanics or the quantum numbers will tell you that yes, it's in this first energy level, principal quantum number. That's the address. We can smallen it by looking for the angular momentum quantum number. Oh, pwedeng nandito siya. Or andito siya sa sublevel na ito. Or andito siya sa orbital na ito and it's spinning upward. So we can possibly find a spot, no, a smaller spot. No, if we compare halimbawa elements on the second energy level, if we increase the energy level, so hindi na siya hydrogen, let's say it's boron, no? Pwede siyang nandito sa S sublevel, no? And within S sublevel, we only have one orbital. Pwede naman nandito siya sa p sublevel with 3 possible orbitals or orientations. So at least we can pinpoint, no, the location of an electron. So it's just like an address, no, but not the exact one. So let's use these values this knowledge into practice. So first is, for the first two problems, we will try to identify quantum numbers given the electron configuration of an element. So how do we do it? No, we do it best. So here we are already, good thing we are already given an electron configuration in a long form. Pwede naman siyang naka noble gas notation. Now we learned this in Gen Chem 1. No, but we are only after the end of the electron configuration or the last electron configuration. So let me copy it here so that will not get confused. That's 4s2. Now, how do I use this information to get the quantum numbers of calcium or of this particular element? No. Knowing the quantum numbers that n is the energy level, I will know that 4 is my n, no, because it's in the 4th energy level. And knowing the values that corresponds to every sub-level, no, the SPDF, I will know that S corresponds to, so ilagay lang natin for reference, corresponds to 0. So S is 0, that's why my L would be 0. No? And take note that N cannot be equal to L because the formula for L is N minus 1, no? Less than or equal to N minus 1. So L should always be less than, no, N. No? It cannot be equal to N. So pag may nakita kayong set of quantum numbers na parehas ang N tsaka L, automatically that's wrong. No? That's a wrong set of quantum numbers or it does not exist. So that's your N and L. You have the first two sets of quantum numbers. Now, the ML, no, M sub L, the magnetic quantum number will tell you the orientation of the sublevel, no, or what we call the orbital. So CS is spherical, therefore it only has one orientation. So si ML will always be 0 if your L is 0, no? And then you have 2 electrons in this particular orbital, so I may write it here 0. I have 2 electrons, and by the Hund's rule, 1 electron spinning up first must be placed, and then another one to make it 2. Therefore, the ending electron is downwards. So my N of S, my M of S, or my spin electron, spin quantum number is negative 1/2. Alright? So my quantum numbers are 4, if I'll be placing it horizontally, 4, 0, 0, 0, 0, negative 1/2. So 4, 0, 0, negative 1/2. Now if it's 4s1, that's a different element, and that would be a different set of quantum number. That would be ms positive 1/2. So no set of quantum numbers would be the same for two different elements. Take note that each set of quantum numbers is unique for every element. So we have 118 elements as of the moment. Therefore, we only have 118 sets of quantum numbers. Hopefully, nagiget. Alright, so that's our first problem. Second problem. By the way, you may pause the video for every problem and try to solve it now before I spoil you with the answer. So here, we are asked of the quantum numbers of oxygen. So sad thing, walang electron configuration. So how do we do it? Again, we do it best. So first, in Gen Chem 1, recall that we can get the electron configuration by the atomic number of an element. So the atomic number of oxygen is 8. So I can place them in the electron configuration. Sir, I forgot already the electron configuration. Or sir, I don't have a periodic table na gagayahan ko nung parang pattern baga. So don't you worry. No, the quantum numbers is amazing enough to tell you how to create your Aufbau principle or your set of electron configuration. So we learned that if n is 1, no, L is n minus 1, so you only have 0 for 1. So this is your n, this is your L. Hopefully nakaka-follow, no? L has a formula of n minus 1. Yan. So dito, kung n is 2, that would be 2 minus 1, which could be less than or equal. So magiging 0, 1. And then 3, magiging 0, 1, 2. Kapag 4, 0, 1, 2, 3. Sir, para saan to? Anong connect? No, sa quantum numbers. So this corresponds to letters. So I can simply replace them. This 0 could be S. This will be S. This will be P. S. P. And sorry, pinatong ko na lang. D. And S. Di ba? Creative P. D. And then F. O, di ba? So that would be 1S, 2S, 2P, 1S1, 1S2, 2S1, 2S2, 2P1 until 2P6, 3S, 3P, 3D, 4S, 4P, 4D, and you can create your Aufbau principle. Place them in a separate paper like 1S, 2S, and then 2P. Sige, para mas ma-visualize, 3S, 3P, 3D, and then 4 na 4, 4S, 4P, 4D, and then 4F. And so then, I create my Aufbau principle. Diba? Using quantum numbers. So, mas maganda yung drawing nyo. So, mahirap mag-drawing ng gamit ang mouse. Anyways, so that's it. No? So, I will just place my atomic number, because atomic number is equal to proton, and in a neutral atom, proton is equal to electron. This becomes 1s2, so 1s2, 2s2, and 2p4. No, I need only 4 to create the 8. And what I'm only after is 2p4, the ending of my electron configuration. So, mas madali kung check nyo na lang sa internet, di ba? But again, we are after the skill. No? Paano kapag face-to-face class na and you don't have the access to internet? No? As long as you've mastered quantum numbers, electron configuration is a piece of cake. So, 2, easily, that is your N. So, your N is 2. Your P, no? SPD, ulit-ulitin natin by law of repetition. We will master the topic. 0 is S. Sige, bear with me. Converge. 2 is D. And then 3 is F. Yeah. So, P is 1. So, my L is... Sige, makisama ka naman. My L is... ibang image na tuloy ang nadodrawing. My cursive L, that's a cursive L, is 1. And then, I have 4 electrons in my P orbital. How do I write that? So I've learned that the P can have 3 orientation. That's why we have 3 orbital. And I have 4 electrons. So that's 1, 2, 3. So I label this first. No, negative 1, 0, 1. If you can remember, the values for the magnetic quantum number is just negative L to positive L. So negative L, 0, positive L. The 3 orientation. And I used to using half spins of the electron or half arrows. Pero pwede naman siyang buo. No, it's okay. Mas nasanay lang ako sa half spin. So, 4 electron. So, it landed in negative 1. Therefore, my ML, though it has 3 possible orientation, the specific element, oxygen, landed on ML of negative 1 on the orbital of negative 1 with a spin of negative 1/2. Negative 1/2. Because it's a downward spin. Sir, question, bakit hindi po pwedeng maging positive L to? Mamamalian ba? Yes, of course. Because if it becomes positive L, it becomes a different element. Because 1, 2, 3, or positive 1, the positive 1 is here, and it becomes P3. It's no longer oxygen, but nitrogen. If you can check, the element before oxygen, that's nitrogen. And then, sir, paano kapag positive 1/2 to? If it's negative 1/2, landing on this one, so that's minus 3 electrons, so that would be 5, that's hydrogen, helium, lithium, beryllium, boron. That becomes boron. That's why, as I've said, each element has each unique set of quantum numbers. Alright, so for number 3, what element has the set of quantum numbers? Now, what element has the set of quantum numbers? So we are now identifying the electron configuration and elements from quantum numbers. So how do we do it? We do it best. Ulit-ulit na. So that's 3, 1, 0, 1/2. So first, we identify the principal quantum number. That's 3. 1. 1 corresponds to S is 0, 1 is P. So the video will lengthen if isusulat ko pa siya. So 1 is P, S is 0, 1 is P, 2 is D, and then 3 is F. So that would be 3P. And then, sabi dito, there's an electron spinning upwards that lands on the 0 orbital. So that's negative 1, 0, 1. So that's the P orbit 3 orientation of the orbitals. It says that there's a half spin electron that lands on the 0 or the O, or 0 orbital. So that's here, that's the second electron. So I count 1, 2. That would be 3p2. And then to write the electron configuration, I can go backward, 3s2, because I know that this is the last of the electron configuration. That's 2p6, and then that's 2s2, and then 1. Oy, nagdo-drawing ako. Where's the pen? Nawala. That's ayaw dun. That's 1s2. So, if we count, we have now the electron configuration. If we count, that's 2, 4, 10, 12, 14. That's the 14th element. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon. The 14th element is silicon. So, I'll answer. If I'm asked of the electron configuration, I can simply write 3p2, or kung buong electron configuration ang inihingi, I'll be writing this dash silicon, Si. So that's how we identify an element given the set of quantum numbers. Naget? Sana naget. Practice number 4. Identify the electron configuration and elements from the quantum numbers. So same ang gagawin. So we have 3, 1, 0, negative 1/2. So I have 3. So, ang pinagkaiba niya lang kanina, dito, positive 1/2. So, ginawa lang nating negative 1/2. So, let's check. 3, that's 1. So, that's still P. S is 0, P is 1, 2 is D, 3 is F. Naka-follow. 3 is the energy level. So, it's always the coefficient before the sub-level, no? Or before the letter. 0. So, it landed on the 0 orbital. Again, 3 orientation. So, kung di alam kung saan to galing, check the original video on quantum numbers. That's 1, 2. It landed on the 0, but it's not spinning upwards, so I should continue. 3, 4, 5. No, it lands on 0, but it's now spinning downwards, so it's negative 1/2. And the electron is 1, 2, 3, 4, 5. So that's 3p5. I count. I do the electron configuration backward. That's 3s2, 2p6, 2s2, and 1s2. I count the electron because it gives me the number of proton and the atomic number. 2, 4, 10, 12, 17. So that's the 17th element. Hydrogen, helium, lithium, boron, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, magnesium, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, 17. Tama, 17. 2 to 6, 10, 2 plus 17. So the element is chlorine. No? If element lang hinihingi, that's Cl. If hinihingi ang last of the quantum numbers, that's 3p5. Alright. Hopefully, nagiget, no? So, for the first problem, we solve electron configuration to get the quantum numbers. The other way around sa 3 and 4. So, for the challenge question number 5, I'll be leaving it to you since medyo mahaba na ang video. So, you are to identify the elements of the following. No? And then, name the biggest element out of these quantum numbers. So, you may comment the answer on a private section or in the private comment once I upload this video. So, ayan, you have 1, 2, 3, 4, 5 elements. Some elements might not exist here. Some elements are smaller. Some are bigger. No? Or, you may solve it individually entirely or you may think, no, as easy as possible, no, para hindi nyo na isolve lahat, which are valid, no, which would be bigger, and so on and so forth. So I'll be not giving any more clues, but there you have it, ladies and gentlemen, a set of practice problems for quantum numbers. Hopefully this helps. Maraming salamat, and yan, be amazed of the mystery of the universe, no, because the quantum mechanics is not really the answer yet. No, there's still string theory and the magnificence of the beauty that is beyond our thinking, no, that's even beyond the universe that we live in. So maraming salamat. This has been Sir Jalo. Peace out.